Hello class, welcome to the lecture video for week 12, day 1. Today we'll be working on costs, particularly long-run costs, but I will also compare and contrast that with short-run costs. And I'll skim by opportunity costs and some costs and marginal costs, and we'll get right to ISO cost curves. So we could talk about firm optimization, how firms can make optimal decisions regarding production. And so how do firms consider production costs in the long run? Probably there's some period of time where firms can adjust both labor and capital. So if you give them enough time, they can buy machines also and have more machines. And so this can be, I guess, personally useful if you want to think about it this way. How do you adjust inputs to maximize your own production, whether that be of work time or grades or whatever? How long do I have is an important question. Should I buy a Peloton, or should I spend some extra time driving to the rec center? You can see how you buy a Peloton, you increase your capital and reduce the amount of time you spend driving to the rec center. So reduce the amount of labor you spend trying to be physically fit, and increase the capital you use in that production to be fit. And so you might not be able to just run out and buy a Peloton tomorrow. Maybe they're out of stock. Maybe you don't have a truck to pick one up. But in the long run, I'm sure you could probably find a way to buy a Peloton, assuming you had the cash for it. So how long is the long run kind of deal is often comes up, and the long run is long enough that you can adjust all of your inputs. And so due to coronavirus, you have to think about all the unused capital that universities have right now. So buildings and the things in them are just not being used. And the vaccine came out the other day, but if the future for higher education were to be online, those buildings, they could adjust those in the long run because they'd be out of the contracts. You might need to increase or decrease people to do that. Just producing online learning is different than producing in-person learning. And consuming it, I'm sure you guys have found to be different also. So short-run costs and long-run costs. Importantly, we've done production in the last week, and now we're doing costs. And so the x-axis is the amount that we produce, and the y-axis is our total costs here. And so in the short run, we have at least some inputs fixed, and this is typically capital leading to fixed costs, and that's this blue line. So regardless of how much we produce, if we produce nothing, we pay $50 for our fixed costs, like our building. And if we produce 10 units, we also pay $50 for our building. It doesn't matter how much we produce, we still have that fixed cost that we can't adjust in the short run. And so in the long run, this picture is a little different because all of the inputs are variable. And so there would be no blue line because there's no fixed cost. All inputs are variable. And since there's no fixed cost, total variable cost equals no total fixed cost, or total cost, period. So this orange line would equal this gray line. So all the inputs are variable, so the variable is total cost. And so our ultimate goal is to analyze what the optimal bundles of inputs in terms of labor and capital is in the long run for a business. And just to tie costs back to productivity here, we have short-run total costs increase at an increasing rate. That is, these get steeper as you produce more due to diminishing marginal productivity, which we talked about. So if you add workers, each additional worker is not going to produce as much, and that leads to this diminishing marginal production, which comes out in this increasing total cost as you increase output. And so I wanted to tie this back to production for a second. And then the firm's optimal mix in the long run. So because they can't change at least one input in the short run, that's why our optimal labor capital bundles are going to be done in the long run, because then we can adjust both labor and capital. And so, like I said, long-run total costs are variable costs. You could set all inputs to 0 if you wanted in the long run, which would make your fixed cost 0. Nothing is fixed in the long run, so you can produce 0 and pay 0. It's fine. In the short run, if you produce 0, you'll still owe those fixed costs. In the long run, the firms are paying attention to their total costs, their average cost, and perhaps most importantly, their marginal cost. Because, like I said, total cost is variable cost. There is no fixed cost. And so how do we represent costs in the firm's optimal decision-making? We use an Isocost curve. which is the firm's budget constraint. So the relative prices of inputs faced by the firm are encoded in this Isocost. And we're just doing capital and labor here, but you could generalize this if you want to. We're just going to start with a cost function with two inputs. So we're going to have C cost equals to the amount of labor we use times the amount plus the amount of capital we use, hours, workers, etc. K is the amount of capital. And we can choose the amount of labor, we can choose the amount of capital, and the costs are constant along this line. So this represents all of the costs equal to some C bar. And this W is the wage rate, so it's just like the price of labor. And this R is the capital rental rate, so it's the cost of capital, essentially. And so what you have here is an x-intercept where on this labeled Isocost curve, where Isocost equals 1,000, if you spend all your money on capital, you can have something like 125 units of capital here, given that capital costs $8. And if you spend all your money on labor, on wages, and the wage is 24, then you can have 41 workers. And any of these costs in between all cost $1,000. And so these are the intercepts of the Isocost curve. And we're going to use capital and labor at these constant prices, which is why the slope is linear and unchanging. And so cost equals 3,000 would be way beyond where the cost equals 1,000 is. And so I haven't changed the W and the R here. I've just allowed the firm to spend more money. And so what we have here is a lot of Isocost curves of equal slopes because they're the same wage and cost of capital rates, except at cost equals 2,000, they use a greater amount of labor and or capital and spend more than 1,000. Spend 2,000 here and 3,000 on this one. And the intercepts are just going to be the same. You could do 2,000 divided by 8, and that's your capital intercept, which is 250. You could do 2,000 divided by 24 and get your labor intercept as well. And so this is really kind of the main point of this, is that we've done production, and now we're doing the cost of production, and we'll be able to put those two together and get optimal decision making on Thursday. And so these Isocost curves contain every input bundle costing a specific number of costs, so C bar. This linearity says that the prices don't change, which is reasonable if there are enough buyers of labor and capital. So firms don't have enough market power. And we can rearrange this so that we can define the amount of capital purchased in terms of the costs, or the total amount of expenditures, C bar, and the prices of W, which is labor, and R, which is capital, times the amount of labor we use. And so this is just saying that the amount of capital we use to stay on the same curve is a function of the labor and trade-off between labor and capital in terms of their price ratio, this negative W over R. And so this gives us this nice graphical representation. And these Isocost curves have a few properties. So I've already defined the intercepts for you earlier, which is just C bar over R. So you could say the capital intercept, if we spend R or if it costs R for a unit of capital and we're spending C bar, and we have zero labor, then we just plop in 0 for labor and solve for capital, and that's our y-intercept on this Isocost curve. I kind of showed you in the 3 Isocost figure earlier that Isocosts farther from the origin are where we're spending more money and using more and capital and or labor. And then the slope of Isocosts are all going to be the same because regardless of how much the firm spends, there's still labor still costs W and capital still costs R. And so the slope of these Isocosts are the same. The change in cost given a change in labor, if you take the derivative of this, you just get negative W over R. And so the slope of this line is the price ratio of capital, of labor to capital. And so it's not too hard. In the long run, firms can adjust all these inputs. And so in the working examples typically used, and what we use, the inputs are labor and capital. And to pick the optimal long run bundle, firms are going to use the Isocost, which we did last week, and the Isocost, which we did this week, which summarize both production and the expenditure required in the market to pick the optimal bundle of inputs for production that either maximizes an output or minimizes an expenditure. And that's what we're going to be working on Thursday. For now, we're done. So thank you for tuning in, and I will catch you on Thursday.